Okay, greetings boys and girls, ladies and gentlemen. This video is going to concern itself with measurements made with a classic general radio type 916-AL RF impedance bridge. This was a staple of the broadcast industry for measuring antennas. One of the reasons is that you can really drive a lot of dBm into the generator port without a problem. In fact, GR specs 30 volts. 30 volts? RMS, I'm assuming. At any rate, you can put a lot of poop into this bad boy and it's still happy. Why is that important? Well, in the broadcast band there's lots of stations and interference and stuff like that, and those big antennas pick up all sorts of signals, which makes it difficult to make a precise measurement because there's so much extraneous stuff coming in. So the 916AL covers from 50 kilohertz to 5 megahertz, and currently we've got a generator, and I'll point up to that, set to 1 megahertz. Ooh, sorry, it's an HP generator. Zoom in here a little bit. Okay, there's the 1 megahertz generator. It goes into an amplifier. That's above here. It's very hard to see, but it's up there. It's an ENI amplifier, and I've got it set to generate 30 volts RMS. Yes, it has a voltmeter scale. So that's the maximum recommended by GR. We're going for the max. Why? Well, we're using a very deaf detector. The detector is not recommended for anybody really using this instrument, but to use a detector with a meter and audio output proved to be too difficult for this videographer. So I use a scope. By the way, this is my highly coveted General Radio Bird Watcher official uniform. Yes, I'm a former General Radio engineer. Okay, now that said, in the background you can, well, actually foreground now, you can see the scope. And I'm using the scope because the visual is better for this video than audio. Audio tends to get gain controlled by the camera here. So even though I can hear a dip in the audio level, you probably cannot, and so we're going with video. It's a stupid detector, but it's going to work for this demonstration. So let's back off here and see if we can get a whole view. Okay. All right. So first thing that you have to do with this bridge is you have to connect a small adapter here. This thing is actually has a resistor inside of it, and there are two of these that come with the bridge. This is the one with the short lead, but there's one with a much longer lead. You plug that in here, and you typically want to connect it to the ground post, because this is a substitution bridge, which means that you take and create an initial balance, and then you substitute the device under test to measure it. And the initial balance in this case is a short circuit. The initial balance controls are down here. And so if I vary this control, this is the resistance initial balance. You can see that nicely. Oh, is that wonderful on the scope? Right? And I'll tune this for minimum sine wave at 1 megahertz. I don't want to get, it takes some patience. And now here is the reactance initial balance. Same thing. And these are very sharp nulls. And again, you wouldn't use a scope to do this. You'd use a detector that had a logarithmic response and a receiver, All right, so there's my initial balance. I've got 1 megahertz going in. this dial scales with frequency. At 100 kilohertz, it reads directly. At 1 megahertz, you divide by 10. It scales as 1 over F. So it's set to 0 ohms. My resistance dial is set to 0 ohms. Let's see what happens when I vary the dial. So here is what a half ohm looks like, and you can clearly see the imbalance, even on this crude detector. A good receiver would be a lot better for fine tuning, but this is good enough for this demo. Okay, so we set it back to 0. First thing we're going to measure is a 50 ohm resistor, everybody's favorite value. So here is a general radio, because it would be blasphemy to use anything else, 874 style 50 ohm resistor. Now we don't have an 874 plug set up here, socket rather. Well, they're hermaphroditic, doesn't matter, plug socket. But we'll use this clip lead here. And I'm going to connect now to the shell with the clip lead, and the center conductor is connected to ground. So as you can see, the bridge is way out of balance. Now let's crank the resistance control. Oh, is that sweet, or is that sweet? And that bad boy, that's about as good as I can get it with the scope here. Let's zoom in on the number, just so you can see the number. Is that 50 or is that 50? Okay, back out. You know, this was built back in the time when things were built proudly in America. All right, moving on. Next thing we're going to measure is a reactance. I have here a toroidal inductor. I've measured it with a general radio, 1687B 1 megahertz LRC bridge, digi-bridge. It's not really a bridge, it's a meter, but let's ignore that. And it measures out to be 18.5 microhenries with a Q of 185. This translates to 116.9 J ohms plus 0.63 real ohms resistance. All right, so what we're going to do, I'd love to leave this as it is. Yeah, so what we're going to do is put it in series, just for now, with this 50 ohm resistor. Two things I expect. One thing, of course, is this reactance dial has to change. The other thing is the resistance may go up a smidgen because the inductor has loss, which is a real, which is a resistance. This is hard to do, getting that connected. I think I'm connected and not shorted out, we'll see. So I'm going to leave the resistance set the same. Change the reactance dial. Oh, look at that. And notice, it's balancing, but it's not quite perfect. We have to change the resistance dial a little bit. Oh my, it's too good. And let's zoom in again. All right. First, the reactance dial. See if this camera can, oh, it's beautiful. All right, that's reading what I would call 1,170 ohms. Now, we take 1,170 ohms and divide it by 10, we have 107 ohms. Remember I told you what the value was, 116.9? Okay, that's that answer. Wow. And now we'll go to our resistance dial. And as you can see, it has moved up. Some might say it's moved up a half an ohm. I say it's moved up 0.6 ohms, because that's the answer, of course. Never ask the question unless you know the answer. Okay, well, if you're not impressed, I can't help you. I'm impressed. This thing is in just beautiful condition. It must have led a very, very quiet life in a dark, clean place for a long time. So, there you have it. I'm not going to go any further with this. I probably bored you to tears. We'll put Squawky back up there, the general radio bird watchers, and that's another thing in the world of today that could not exist. Why? Because of political correctness. It was a very politically incorrect organization. And that's it from the Bat Cave. Signing off. Thanks for watching. Over and out.